So, shall we start, sir?
Yeah, sir.
Yes, sir.
Okay, thank you, sir. Good morning, all the participants, and welcoming to the today's presentations and FDP program conducted by the BIT SINDRI. And I'm going to deliver my session today on chatter reduction in high-speed machining. A chatter reduction, a chatter that is an unavoidable phenomena. It is like a vibration in our day-to-day life. Now, let me understand what is the significance of that. Now, in today's world of manufacturing, we are require a higher production rate, and that need the high-speed machining. We require a more amount of manufacturing, higher production, finer production, accurate machining, along with a lighter and compact size of a machine tool. That is also the requirement. So, as we are increasing the production rate and reducing the weight and size of the machines, it leads to the high amount of vibrations and chatters. Means we have a machine tools with number of assembly of parts, means that increases the non-linearity, a multi-degree freedom system that brings into the picture in productions, and variety of operations. As we are aware that on a CNC machine we can perform the number of turning operations with variety of attachments. So all these attachments are increasing the number of degree of freedom increases in our machine tools, and as degree of freedom are increases, more nonlinearity induced into the system. So ultimately, it reaches into it result into the vibration and the chatter. So we have to try to understand that what is the difference between vibration and the chatter, right? What is the vibration and what is chatter? So I can say that in vibration and chatter, if I discuss, so before that we have to also understand the difference between oscillation and vibration. When we are talking about oscillation and vibration, oscillation we are learning from, I think, school level. This is the oscillation, that simple pendulum problem we are learning, and we cram out that equation of oscillation. And when we are in engineering and start learning the vibration, at that time also we are solving the same pendulum kind of a problem, and at that time we are using the term vibration. So what is the difference between oscillation and vibration? When we are considering the mass of a body in oscillation calculation, at that time we term it as an vibration, and we are neglecting the mass, and we are talking about that is oscillation. The same thing with the chatter. There are the vibration considering the mass of there are the chatter, it is considering with the it is considering with the ma the chatter, that what we are considering as a self excited vibration, that is the chatter. While in vibration it is a self applied externally applied force, and that causes the vibration. While in chatter it is a self excited vibration. That is the main difference between vibration and the chatter. So in this presentation, we are going to discuss about the chatter reduction overview, simulated multi-degree of freedom plots, mathematical modeling of CNC turning and stability lobe diagram discussion, computation analysis, and some experimental work based on the for the chatter, and the further results and conclusions. So as I discussed, the chatter is a self-excited vibration which extract the energy to start and grow from the interaction between cutting tool, workpiece, machine tool, and all other interactive component or a machine tools. Means chatter is a phenomena of a machining process, while vibration is a phenomena of that particular component. This is the main difference between chatter and vibration. Vibration of a machine tool, vibration of a cutting tool, vibration of a workpiece, but chatter of turning process, chatter of milling, chatter in phase milling. So this is the terminology difference. Chatter is the result of self-excited vibration, right? So the chatter is going to detrimental the finished surfaces, and it reduces the life of the cutting tool. Now, what are the classification of the chatter? Chatter can be classified as a primary chatter and the secondary chatter. Primary chatter generally comes uh, in a steady state condition, and the most type of a chatter, that is a regenerative kind of a chatter, which all the researchers are in it, keep in mind for the further research as a future scope of research. So that is a regenerative chatter. So the primary chatter that generally happens at a low cutting speed, and secondary chatter that causes by the undulation of the surfaces at high spindle rotation speed means. And here we can see that uh, the chatter surface over here, mean chatter surface over here, how we measure the chatter. We can one can measure the chatter with using the 3D metrology tools. What we are measuring in the chatter? We are measuring the waviness. We are measuring the waviness of the surface, not the surface roughness. Right? I hope all of us are very clear the difference between surface roughness and waviness. Right? In technical term, that measuring the surface roughness for longer unit of length, that is considered as the waviness. And if I would like to give you one simple example in a non-technical terms, then if let me take like that, if one can driving in a mountaineering terrain like a Rishikesh and upstream, so what will happen over there? The roads are very good. Roads are very good, but there are the up and down terrain. So the surface roughness is good, but waviness is not good. So this is in this way one can explain to the students the difference between waviness and the surface roughness. So the chatter is also measured with waviness, measuring the waviness with our metrological equipments. And then we can further go for the diagnosis of chatter and reduction of chatter. So chatter, if overall, if I'm concluding what is chatter, so this one picture I had created over here. The chatter is a self-excited vibrations out of types of two kind of a category. The secondary chatter is the area of interest of a researcher. It is definitely unpredictable and anomalous phenomena, and there is no external energy required to cause the chatter. Right? We will discuss. So now our main focus is on the regenerative chatter. So regenerative chatter, it develops at one of the neutral mode of a cutting tool system. Again, neutral mode of a cutting tool system, including the tool, workpiece, machine tool, fixture, etc. If the amplitude does not diminish, if amplitude does not decreases, chatter develops and create the waviness on the machine surface. Means we have to reduce the amplitude of vibration to minimize the chatter. During the next pass of machining, we will understand more clearly in the next slide by picture. During the next pass of machining, these wavy surface amplifies the amplitude and it creates a regenerative chatter, and ultimately it make the system unstable. Yeah, this is the figure of regenerative chatter. As you can see here, the red line is mentioned over here. That is with the that is with the workpiece profile. Workpiece profile. Okay. Now, our machining is start with the this one. Our first cut tool trajectory. First cut tool trajectory. So as you can observe that during this first cut, during this first cut, it is going to remove the material up to here, and then at this point, at this particular point where I had marked that vertical black line, right, at this particular point, at this point, what will happen at this point? At this point, what will happen? The cutting tool is in contact with the material, is suddenly disengaged from the material. Means whatever energy stored here during this cutting operation, it suddenly releases at this point. And after a fraction of second, that tool comes in contact again with the material. So this much gap, in these gap, if point number 1 and point number 2, okay, so if this span is having that much time that my tool can damp out or settle down its neutral position, then there is no problem. But we don't know these distance or a timing. If material releases from here and before it neutralite or a damp out, it again start the operation. So there is an self-excited energy is releases over here. Okay, the same thing will happen over here when it come out of this contact, come out of this material contact. There was a sudden disengagement with the workpiece, and that this particular tip is going to a little bit harden out, and these 2 points has been clearly shown as a mark on the surface, and we measure this as a waviness, or that is a very clear chatter was indicated on the surface roughness, right? Why it is too complicated? See, still there are number of mathematical model has been created, and of course the if we talk about the history of chatter, so first of all, the machine tool vibration was given by F.R. Taylor in 1950s. Somewhere they introduced this term, machine tool vibration, and in 58 onwards, the particular word chatter has been popular among the researcher society, and they are then after number of mathematical model, but official, or we can say the more reliable model yet to be developed by the researchers, because there are lot of non-linearity in the system, right? Whatever the models are available at present, whatever the model available at present, all those are with lot of assumptions. As we are aware, models are generally prepared with the assumptions, and they are with considering the linear variation in chatter. Yes, yes, linear variation in chatter. Because in actual condition, but in actual condition, but in actual condition, in actual condition, in actual condition, there are number of non-linearities that comes into the picture. Like as we can see that there is a second cut tool trajectory has shown over here, and shown over here, and in the second tool touching now the next pass, when the next pass will taken place over here. So what will happen when next pass of operation will take place at that time? What happened? The material is going to remove from this much end, is this much end, right? As you can see here, it's from here, this and this. So this one is the another, the second pass. What about the third pass? In third pass, it's totally within the workpiece, so there is no possibility of the waviness or a chatter are on the machined surfaces, right? So when these are the region which causes the chatter. I hope in these way we can understand the regenerative chatter. So as more amount of amplitude, so that sentence utilized in the last slide, more amount of amplitude, as we are in decreases, as there was a sudden change in the energy, it ultimately be suddenly strike on the surface, and that increases the amplitude of vibration, right? In that way the system has been written. So I hope we are understand the chatter phenomena. and how exactly it working. Okay, now what are the causes of chatter, a drawback that causes by the chatter? What are the problems created by the chatter as listed everywhere? Poor surface quality, excessive noise, tool wear, and decreases the tool life, reduces the MRR, and increases the cost in terms of the production time. Sources of chatter. So these all are the inhomogeneous workpiece material, hard spot, the breaking away, the build-up age from the tool phase. That's what I had discussed. Breaking away of a built-up age from the tool phase. I had discussed with the work surface. The same thing may happen with the tool phase as well. Non-uniform work hardening of the layer being cut. So uh, these all are the sources of vibrations or sources of chatter, we can say, right? These all are unavoidable. These are all are unavoidable conditions. So there is, we, if one can say there was a basic method of chatter elimination, no, there is no specific. Yeah, there are effective chatter reduction methods, but they cannot not claim that there is 100% chatter reduction. So what are the pre-installations? And I have to say that the basic method of vibration control rather than chatter eliminations, right? These are the four options. You install your machine tool properly at foundation, use the cutting fluid, magnetic cutting fluids if it is required in a high speed operations. Check the dynamically balanced machine tools. An installation site is free from the surrounding vibrations. These are the pre-installation check and during the operations, some of the vibration elimination methods. Now, method to control the vibrations. So there are a number of methods, but it broadly classified as a process method and the structural method, right? A process method. Process method is the changing the cutting tool data, changing the cutting data, and structural method that introduce the damping, the structural parameters. Process methods is going to give the offline method and the online method, and structural method is given classified further as an active method and the passive method. So this classification is made by my research team, because still we are not having uh, there are a number of researchers are classifying this chatter reduction techniques in a different way. Okay, so on basis of the literature review, we had classified in this four category: the process method and the structural methods. Process method is the offline and online, and structural method as an active method or the passive method. All of us are aware offline process method and the online process method. We will more discuss with this. So now, based on our number of literatures from recent years and most citable research we take in our literature review, structural methods, there are most of the work has been done in a structural method, either passive method or the active method. The reason, the reason is that the passive method classification, the passive method classification, the more number of research has been done, because the passive method structural is more applicable, more utilized, easy to implement, easy to modified, and cheaper in cost. Yes, these are the main benefit to go with the passive methods. Active methods, there are in active methods there are on time vibration tables. They're costing too much, right? A simple vibration table of size of our conventional office table, that was costing more than 15 to 17 lakh rupees. Active vibration table, right? So one can go with that machine tool or measuring tool. As far as process methods, in process method, offline and online. In online process methods, very few researchers where complete automation is there in industries. So few Japanese researchers had published their work in that area. Apart from that, we are not finding much research work from any other part of the world. So, on basis of that, we are focusing in passive methods. So, process methods, one can say the active method, and structural method, one can say the passive method. Again, there was process method and the structural method. Process method, during the operation live, one can use the conventional cutting fluid. One can go with the MR fluid to reduce the problem of waviness or a chatter. Second, spindle speed variation. In live operation, we are reducing the spindle speed. And sliding head machine tool. We are having the machine tool with changeable sliding head. So these are the methods we are utilizing to control the waviness or vibrations. If we talk about out of these three, if one can ask which one is more preferable or more acceptable in the industries, so that is what the SSV, spindle speed variation. What is the spindle speed variation? Of course, those are the faculties are very much clear about the SSV, and I just talk a little bit about for the students or researchers are joining with us. Spindle speed variation. There are a cutting speed and spindle speed. These two are a different thing. Generally, the question is going to be asked in a viva. What is the difference between the cutting speed and the spindle speed? Is it? Because spindle speed is a constant on your lathe machine or conventional machine. Your spindle speed we are changing with the gearbox in our manual lathe machine. So that spindle speed is remain constant until you change with the gear during the operation. But your cutting speed is going to change. Why? Because during the cutting operation, whereas you are taking the number of depth of cut, so effective diameter is going to reduce step by step. Is it? So when this will happen, so ultimately what happen? For same parameters, depth of cut, feed, cutting fluid, I remain for different cutting speed. That is not acceptable, and that causes the chatter. So what we require? We require a certain kind of controller, automation that change the spindle speed as per the variation in depth of cut, right? So that is the SSV modules are available in harsh controller or a Mazak controller. And in India, Siemens is trialing to develop the that kind of a controller, but yet not that much successful controller we have, particularly for SSV module, right? If the if anyone those who are having utilizing the CNC machine or a controller of EMC and CNC, so general our preferable controller in India we are having the Fanuc or Siemens. And apart from that, in industries, we are having the Mazak, a Japanese controller, Harsh, a US based controller. So these are the well known controllers are utilized in our industry. So over there, Harsh and Mazak, they are having these SSV module and implemented from last decade, we can say that. Yeah. But apart from that, there are not that much there is no not much I can say the controller has been given or developed by the other manufacturer. The reason is still with using the SSV process method or active method, still to reduce the chatter, industry has to go with the structural method or a passive method, right? So then our conventional lathe manufacturer, lathe user or operator, instead of investing a lot of rupees in a SSV module, they would like to go with the more research trial and error on the passive method or the structural method, right? In structural method or a passive method, it's our conventional way by our operators. We are using the toolbar, a hollow toolbar, means weight reduced of the tool. Outside damping, we are utilizing laminating the cutting tool. And now the newer idea that using the same material, using the outside damper. Generally, when we are working on the lathe machine, so the operators are generally place some packing below the cutting tool. It is nothing but to improve the surface roughness. When you ask them, say, yeah, to improve the surface roughness of, to increase the smoothing of operation, right? So that is the outside damping is placed over there. Then researchers go with some more chemical and all that development, and they suggested the laminated cutting tool. Then after, in 2012, 2010 onwards, concept of using the same material. This concept of same material is only 10 years back. Yeah, before 10 years back only, officially the research has been started on the same material, and they are experimentally justified that using the seam is one of the passive chatter reduction technique, right? I didn't say that ssv is not enough. Yeah, ssv spindle speeds are there going on, but even then, after a certain life of that machine tool, there are a chatter, and to reduce that, we have to go with the outside damping technique. So earlier, the outside damping technique is used by the operator, but now instead of that, a predefined seams are going to be manufactured by the tool manufacturers and provided along with the machine tool. At present, uh, the Sandvik, they are manufacturing the tool for larger diameter. If we talk about the milling, so more than 120 of diameter, and that milling tool, they have an option of the machine tool with the sim, right? Now in that, we try to justify that what will happen. Yeah, so these are the sim. So now we are diverting our topic particularly for the application of the sim. As you can see here, a very simple of the CNC turning tool with the seam. So in that, this one is the insert, this one is our cutting tool, and this one portion is the sim, right? This is the example or a live photo of our boring toolbar. So this one is the engine room, and this one is the boring tool. So this is the
Sorry,
so these
sir.
are
You were not audible before.
hello.
Yes, you are audible now.
Okay, so I'm audible, huh?
Yes, sir, you're audible.
Okay. So this is the example of a phase mill tool with sim and without sim, right? And these are the few pictures of the sim. So till until discussion, I am discussing about the chatter and its chatter control techniques, particularly. And now overall, our discussion is focused onto the application of sim. So for that, as I mentioned, we would like to study the mathematical modeling of turning operation, and and then experimental work has been carried out. And my research team is working in this particular topic from last 3 years, and two PhDs is working on this, and their presentations I had been shared with you. So first of all, when we start with the mathematical modeling, some prerequisite. is MATLAB programming, right? All of you are aware about the vibration subject. So in that, simulated result of multi-degree of freedom with stiffness and mass variation. As you can see here, my research team has developed the multi-degree freedom system responses. There are three masses. There are three masses with K1 is 40 and then K4 is 180. This one is a K1 and this one is the K4. This one is the K4, right? And mass 1, 2, and 3. So generally in a books and everywhere, you can have a MATLAB program ready-madely available for 2 degree of freedom system, right? This 2 degree of freedom system. Here we have developed the 3 degree of freedom system. As you can see this. Now, when we are going to change this, now see the variation in the plots by simply changing. Now my K1 is 180 and K4 is 480. And we can see the responses of the system. Mass is remain. There are a number of options, but only I would like to show you this. This is the initial step one can start to explore this topic. Then we are mentioned, we make all the stiffness are the same, masses remain the same. Even then, there are the variation in responses of each and every mass. It is not compulsory that all the stiffness is same and mass is same. So even then also you are getting the same responses all of all the three bodies. It is not compulsory because their initial positions are remain the same. If I'm going to change this initial position, and it is there is no mathematical model, no equation is available to justify the initial position that generally researchers are doing in trial and error method. Means the conclusion from this slide is that even though we have the similar stiffness and the mass, the output of this body is not in the same dynamic motion, right? See, uh, in our research community and in our study, vibration is one of the topic of dynamics. Now, I had talk a little bit diversify, and this is the last for your understanding. Here, now, the K4 is 0. It's a one and free, and we have developed this. And there are number of responses has been developed by my research team, and we are working on this. So, why I'm showing you this? Just to give you a little bit idea about the dynamic motion behavior. Dynamic motion behavior. It is a very interesting and a wide topic. Now the first question comes, why we have to study the dynamic motion behavior? And why we have to study the dynamics? Before we go with the dynamic motion behavior, the first thing, why we have to learn the dynamics? Dynamics, it's a pre-designed subject. It's a pre-designed subject. Yes, number of students are interested to be a design engineer. So those who want to become a design engineer, for them, dynamic is essential. It's a pre-designed subject. And those who want to make their career in a production, for them all also, dynamic is essential. But of course, in our regular graduation studies, we have only one subject of vibration. That only give you our idea about the dynamic study. So exactly dynamics or a dynamic of motion. Why the study of dynamic motion is essential? I'll give you very one uh, typical example, non-technical example. All of us are driving a vehicle, right? Two-wheeler or a four-wheeler. Very simple question. Just ask yourself. I don't require an answer. When you are changing the gear from up to the first gear, let's say your vehicle is running smoothly up to the first gear let's say up to 20 kilometer per hour. When you change to the second gear, when you change to the second gear, what will happen? Your speed is 21 kilometer per hour? No, right? It is always 24, 27, 28, or 30 kilometer, but not 21. Why? Why? Because that is the region, that is the speed region, which is a chaotic. That region is that should be avoided by the designer. That region must be avoided by the designer. That region must be avoided by the operator. When you are in our conventional length, we have some speed range from one speed to the another speed, but there is some variation. Some speed range is missing. It is intentionally missing because that speed range is not good for the machine tool. That causes a more amount of tool vibration, right? So that is the reason. With this example, I would like to discuss the significance of dynamics of motion. We are learning the dynamics of motion, we observe it, we diagnose it, and identify the region that should be avoided by the designer, right? We know how to design something, but dynamics is give you the idea in which range you should design. I hope I had a touch a little bit diversified topic. Now again come back after that mathematical modeling prerequisite. Again come back to the turning operation. This is the turning operation conventional figure. As you can see that when we talk about the turning operations, in turning operations we are having the three direction forces: tangential force, radial force, and the feed force. These are the three forces, right? Now tangential force, and according to that we are having the orthogonal force system, right? The mathematical modeling, due to the wide variety of inserts, why we again some of the people may ask, so when experimentally the things has been developed, then why we should go with the mathematical modeling? We should go for the mathematical modeling because there are the wide variety of inserts, insert material, shape of inserts, and workpiece materials are changing day by day. So if someone is coming with the new kind of a material, so if I have a model, by changing the properties, I can justify the stable range of the system, right? And we optimize the cutting parameters. That's why the mathematical modeling is required. Now here, for this FDP, I have only taken a very simple kind of a model system. Lump mass model system has been given. Here, this model is without seam, and this model is with seam. This assumption has been taken. The y direction right now is not discussed in today's presentation. Only in one directional analysis has been made in today's presentation. So for that, we make this assumption. The present mathematical model has developed considering only tangential direction movement of the model. Material is considered to be the homogeneous, and there is no spiking due to the cantilever extension of tool, that is not considered. And all the force system in this simulation is considered as an orthogonal force system of turning operation. So these are the basic ideas or assumptions has been put into the picture while creating the mathematical model. Then a conventional Euler-Lagrangian equation has been derived. Standard vibration problem has been, equation of motion has been derived. Mx1 double dot plus k1 x1 minus k2 x1 minus x2 for 2 degree of freedom for the first model without seam model, right? Then that has been solved. The second order differential equation, that second order differential equation has been solved in the MATLAB software, and before that we have to utilize the state space formation, or we can say the state space variable. These are the state space variables. These are the state space formations, some other variable for converting the second order differential equation into the first order differential equation, so that we can easily solve with using the ordinary ODE23 command available in MATLAB, ordinary differential equation of 2 3, that we can solve over here, right? Similarly, this is there for the 3 degree of freedom system, and we are discussing, yeah. So we are having a 3 degree of freedom case, and that what the similarly we are going to solve that equation. So what are the procedure? The solution of the equation of motion is made with the finding the values of the mass, kc, and the forces, getting the equation of motion with the help of the mathematical modeling in matrix form, use the state space formation, convert it into the first order differential equation, use the matrix operation and get the final form of equation in MATLAB. And with this OD23, we get the results and we plot the different values and then analyze the plot. Now the question comes, how to find out the value of mass K and C? Mass, by weighting the our different equipments, insert seam and the cutting tool. You can weight directly, and by density you have the mass. Value of stiffness and the damping coefficient, C. Stiffness. Stiffness we measure with using the tap testing or a harmonic testing. With that, and C, a computation damping coefficient that we measure through computational analysis. So computational analysis also we made over here. With the harmonic motion analysis, we are having its value, right? By making the model preparation in that Creo, assigning the engineering material and all that things, boundary conditions is given. And then we are generating the harmonic analysis. So from that harmonic analysis, frequency responses are getting. So ultimately, this work is there for utilizing a different seam material. As you can see here, so we are getting the damping ratio with using the half power band method. We are getting the damping ratio of the system in carbide, aluminum, and brass. So you can observe here, brass is having a very lower damping ratio, and carbide is having a higher damping ratio. I'm not saying good or bad, right? This is higher and this one is lower, right? I'm going to discuss a lot more on basis of this. I'm going to get you a lot of idea and topic of discussion, right? So with the computation, we are getting the value of C, and by measuring, we are getting the different values in that. Insert those values. The values of stiffness we are taking by the hammer test, and the forces are considered as per the standard equations given in the design data book, and one reference of Iskova force designing by the machine tool in turning. From that reference, we are taken the force of 295 Newton in turning operation. Right? We have a range, but for this simulation, we go with this force. As we are changing the parameters, the value of force is also going to change in that equation. All that part I'm not discussing. That modeling is very clear to everyone. A variation of force, right? Now we come to the outcome. What are the outcomes we are utilizing over here? What are the outcomes we are utilizing over here? We are utilizing the dynamic motion tool. The first one is the time response, second one is the FFT response, and third one is the point care. Point care map that give you the better idea. That plot is between the velocity and displacement. As you can see, the velocity and displacement diagram. FFT, that is a mathematical formation of that signal, give us an idea about the frequency. The first one is the time response that gives us the idea about the amplitude of vibration. Okay, so now when we are talking about this, what we are getting out of this? As we can see here, with using the FC without SIM, In the without sim, we are having the chatter frequency at round about this values, and that was significantly reduced when we talk about the with sim. And more interesting outcome we had observed with the point care, because in the point care we can see that without sim the system is more chaotic at low speed, because this is the case of 300 on the top. This is the case of we see 300 meter per minute, zero point 0.2 mm per revolution, and depth of cut is 0.5 mm, right? And this one, this is a multi-orbital responses, right? And apart from that, you can see here a beginning of the net structures. This is more stable dynamic motion. Stable dynamic motion. I didn't say stable operation. Okay. When it is checked from dynamic motion stability and stability of process, then and then we can say, yeah, this region or uh, this input or this process parameter is acceptable. This is the another one at 400 meter, and depth of cut is zero point 0.5. Now speed is increases, speed we kept constant, and when speed is increases to the 400 meter per minute, right? As you can see here, the chatter frequency is drastically reducing, and dynamic motion is also here see, as you increases the speed, in without seam operation, the system is having little bit reduced multiple orbit behavior, right? And here with seam, similarly, amount of chaotic responses are reduces as compared to 300 meter per minute speed. When we talk about the yeah, when we talk about the next slide, the same thing. Now in the third one, VC is 400, and depth of cut is 2 mm, and depth of cut is increases. You can see here this picture is more clear, means dynamic motion is leads toward this stability, and as well as time responses also give us a very clear idea at high speed. At 400 this and 402 mm, the frequency, the reduction in frequencies is clearly measured over here, that is reflected in FFT, and multi-orbit responses are also reduces, and cyclostationary responses has been observed in with sim, right? So what we did overall, so now here this experimental analysis has been carried out, sorry, simulation has been carried out in 9 set for cutting speed 300, 350, and 400. Means my spindle speed is 1800, 2100, and 2400, and rotational frequencies are this. So these are my rotational frequencies are recorded in my simulated responses. When we observe that, it is very clear that as we are increasing the speed, then only the utility of sim is more effective. At low speed, we are not having that much a variation in the frequency. But as we are increasing the speed, there are a little bit change in frequency, right? And that is more effective while we talk about the chatter. And when we are behaving the dynamic motion over here, up to 350 without sim, it's a multi-periodic, a very clear multi-periodic periodicity is observed. And at the high speed, the multi-periodic, it tends to chaos. It's a chaotic, which is that dynamic motion which is not acceptable by the design engineer, right? So when we are without sim, we are going So as from dynamic motion point of view, we are not having acceptability at high speed. But with sim, we are having a dynamic motion is remain the same, and quasi periodicity is very clear, identified with the net structure. So this is the one method when we are having a clear cut net structure. This is what you can observe over here. But a clear cut net structure is developing at high speed, means the system is going to become the quasi periodicity. So it is a little bit better than the chaotic. Chaotic is not acceptable, but quasi periodic motion is acceptable by the designer. So from this overall conclusion, we are discussing only the three main things at a high speed, because a significant responses are observed at the high speed. So that one, two, and three, these three cases has been displayed over here in our discussion. And here at high speed, we are having a net structure clearly shown over here. When we go with the 400-meter and zero point 0.5 depth of cut, there also we are having the net structures has developed over here. When even you go with here, this is also clearly indicating the net structure. So this net structure is, it's throughout for all the reading we are having, we are getting the net structure in the figure. So we can say that the quasi periodicity is observed. But as we are increases the speed, right, as we are increases the speed, that the net size is become minor and minor, and that is a good sign of the system motion is leads toward the stability, motion stability, right? So these are the some of the output, these are the output of the our computational model we are getting. Now the same thing, a mathematical, my second team had developed that stability lobe diagram, because when we talk about the chatter, so stability diagram must be developed by the researcher. Yes, sir. Yeah, somebody is raising the hand. Sugnesh, a host. Any doubt?
So we would be taking the doubts at the end of this session when you complete your lecture.
Okay.
Thank you.
Yeah. Yeah. So stability lobe diagram is also the mathematical model has been developed by my team, and that is considering the assumption made by the Dr. Mohit Law from IIT Kanpur. Its video is available online, right? So that assumption has been taken as it is. That is given by Dr. Mohit Law from IIT Kanpur, and on basis of that, we had developed this stability lobe diagram. I'm not going discussion about that mathematical model, and only how to read the stability lobe diagram. On x-axis there is a spindle speed, on y-axis there is a depth of cut, and these region, anything is outside this one region is known as the unstable region. So this much region is the unstable region. All this region is unstable region, right? All this region is the unstable region. All this region is the unstable region. And these are the region is a green color below the yellow highlights. That is a stable region. And above that, all are the unstable region. So what is significance of this SLD, stability lobe diagram? This help a designer to identify the speed with higher rate of production, with higher rate of production, right? Why? As you can see here, the same 9 experiment has been conducted over here, 1 to 9, right? With 300, 350, and 400 meter per minute. There's a cutting speed is mentioned over here. So what will happen? The reading number 6 and 9 are in an unstable region, Reading number 8 is a boundary conditions, and rest of all 1, 2, 3, 4, 5, and 7, right? 1 and 8 all are in a safe zone. We can say it is acceptable. Now, here we are in this, we are having, if one can say to increase the rate of production, one have to go to higher speed? No. To increase rate of production, from this I'm having a conclusion that at these rpm, somewhere at these rpm, if one can operate the machine, so they can go with the more depth of cut. It means there is a more mrr and more rate of production. So if someone would like to increase the rate of production, then one has to select, a production engineer has to select the appropriate range of spindle speed and depth of cut, right? That is the conclusion or outcome of this idea. And from that we are getting, from this we are getting the main idea about the stability of machine tool, right? Dynamic motion is give us the stability of process, and here stability lobe diagram that provide us the idea about the stability of machine tool. So this is what the important things when we talk about the chatter. So stability lobe diagram is always be there, and this is the conclusion. And one more thing about the stability lobe diagram is this: when you develop the mathematical model of a stability lobe diagram, so important thing is that as the damping ratio is decreases, as the damping ratio is decreases decreases, the stable region is decreases, right? This is the important outcome of stability lobe diagram. When the damping ratio is decreases, the stable region is also decreases. If you go back to the computational analysis, in that I made that statement: when damping ratio decreases, dynamic motion improves, right? But stability lobe diagram outcome, when damping ratio decreases, the stable region is also decreases, right? So production engineer has to find an effective damping ratio, means a seam material and cutting parameters, and this is the open up the new area of research topics at MTech, PhD at all levels, right? Now we go for the next. So, so now we go with, this is the amount of mathematical work has been carried out, and now we proceed further for the experimental work. I hope this thing is clear to all of you. Here, I made this comment: when in mathematical model, outcome is that when we are decreases the damping ratio, the stable region is decreases, because all this chart, all this yellow line, the curved yellow highlighters that are moving down, means the stable region is going to reduced. But when you are, when you are making a computation analysis, we are making a computation analysis here, I made this comment in brass. When we go with the computation harmonic analysis of this, in that the brass is providing us zero point 0.00 lower damping ratio, and carbide is having the higher damping ratio. Now keep into the mind, and we then talk about the experimental work, because there are a lot of experimental work that I'm going to discuss, and the conclusion on basis of that. Now this entire work has been justified with the experimental presentation. So for that we are using that CNC turning. Our workpiece is an aluminum alloy 6063 T6. Diameter is 60 mm, length is 130 mm. Cutting speed three set of cutting speed has been set: 300, 350, and 400 meter per minute. Depth of cut 0.5, 1, and 2, and feed is 0.25. That keep constant. And here in experiment, we are using a three different kind of a seams: carbide, aluminum, and brass. And the fourth operation we perform with the without seam, right? And we are measuring the vibration amplitude and surface roughness from the responses. Surface roughness we measure just to support our dynamic motion behavior study, right? So at our institute, we are having a very good skill development center, and this is the Startup India manufactured CNC machine with Siemens controller. That what we are having, and these are the machine specifications as mentioned. We are also having the Coco 80 dynamic analyzer. Very few institute may have this vibration analyzer equipments, and this is how we are attached. The figure 2, the sensor attached with the tool has been shown, and experiment has been carried out. That's why we are the y direction right now. We are simulated, that is in a tangential direction. As you can see, the y direction. So we are only simulated the in a y direction, and next we will develop the x direction simulation, and that combination will give you a much better idea. Okay, Coco 80 dynamic analyzer, that is having a wide range of range of frequency to measure from 0 to 10 megahertz, and depending on that we have the very good sensors with us so that we can capture the vibration signals properly. These are the live photos of oh, this is actually the slides from my second student who had worked on a boring bar. So just I take the very one good figure, the workpiece, and everything has been shown over here. And surface roughness tester only, which the surface roughness part is only a supporting part. That's not a main part. And this way, the actual boring operation has been carried out. Nice pictures I would like to show you, nothing else. All things had been discussed earlier. And we respond to the time response plot uh, that I discussed in a simulation one. Now, experimentally also we had collected all that. From that data, we process those data and analyze the system with the time response plot. So from the time response plot, we are getting the acceleration and vibration amplitude plotting against the time. And for that, we are measuring peak to peak value as an amplitude. In that time response plot, we are having peak value, average peak value, and peak to peak value. Here the amplitude has been measured with peak to peak value. Then the FFT is just a discrete Fourier transformation using the more efficient algorithm takes the advantage of the symmetry in sine waves. So FFT is known to us. The third one is the Poincare map, that the velocity had plotted over here. This is the carbide and the brass seam. Yeah, you can see this. Experimental data, experimental photos, not simulated. 400 meter per minute, zero point 0.5 depth of cut, 400 meter per minute, zero point 0.5 depth of cut, carbide seam and the brass seam. So from dynamic motion behavior, one can say that brass is better than the carbide, right? Brass is better than the carbide, but brass is having less damping ratio, means stable region is decreases, right? This is what I would like to point out the important point. Means designer has to design according by considering the damping ratio, and operator, a manufacturer, has to keep into mind the stability lobe diagram to set the its cutting parameters. So the study of dynamic is significantly important for designer and manufacturer both. This is orbit plot, experimental orbit plot. I am not discussing more about it. Now this is the comparison of theoretical and simulated and experimental work. that is clearly indicated over here, the mathematical and experimental work. At the first case, 300 and that it matches properly very well. Then at FC, this is all diagram for the without sim. What do you observe? This is the without sim. So FC exactly roundabout at some 600 or 550 at 300 RPM. And over there, we are having something around 700 in experimental, but a clear peak is observed. And point care maps are also matching very near to each other, experimentally and simulated, with single degree of freedom mathematical simulation only. When we go with the second model, that also give us a very good and clear indication. When there was a chatter, so you can see or you can mark here a clear cut breakouts and time response, and there are the number of side bands is observed very clearly. These are the side bands. These are the side bands with that value of FC, right? Also go with the fourth one, that is with the, these are the at 400 RPM, 400 meter per minute, zero point 0.5 depth of cut with sim. The first case number 3, that is we are having, what is the outcome here with sim? We are having the very good net structure at 400 meter per minute speed, and point care is also very good. The last one. So what is the outcome, the important outcome of the experimental and the simulated work? A significant chatter frequency. It is very clear that at a low speed, in simulation and in experimental, we are having a significant clear peak of a chatter frequency. But as we are increases the speed, there is a modulation of rotational frequency, and the chatter frequency is observed in simulation and in experimental. In experimental, we are having modulation and its harmonics as well. Both has been recorded in experimental one. So with all this, what is the outcome of the presentation that I already discussed number of times, that the stability lobe diagram, that damping factor, that lowering the damping ratio, that increases the piece increases chatter in turning process. Simulated FRF response clearly indicated the chatter frequency is reduced with the utilization of SIM in a cutting tool, and simulated result has given validated the experimental result. And FRF experimental result is the chatter frequency is showing the modulation of chatter frequency and the rotational frequency. These are the outcomes. And now I'm not going to discuss, I think time not permit, I think 11:15. So we kept 20 minutes for question answer session. So just show you the important one of that. Motion analysis of turning operation has been carried out without SIM, carbide SIM, aluminum SIM, brass SIM, and the outcome is that in peak-to-peak displacement, brass SIM is a better as compared to all. In quasi-periodic, in motion, brass sim provides the quasi-periodic 10 to chaotic motion. And so overall, even that is supported by the surface roughness. In surface roughness, the brass sim is average is 1.8 micron, while these others are having a more values of surface roughness. So on basis of all this experimentally, we can say that the brass sim is better as compared to the carbide sim in turning operation. The same thing, the results of the boring operation has been shown very clearly and stability in one, carbide, aluminum, and brass. So that also lead to conclude the same thing in dynamic motion behavior. Also, quasi-periodic, chaotic only we are having at very low RPM. Yes, it is not always, no, don't be in that impression. We have the chaos only at the higher speed. No, at low speed, the systems are more chaotic. And at higher speed, the system may chaotic, may stable, right? So there are a lot of non-linearity there in the actual field. So based on the motion behavior of this plot, analysis are the summarize by 300 meter per minute cutting speed. A quasi-periodic behavior is applicable only in the case of a brass sim At 220 meter per minute cutting speed, a preferable behavior varies dramatically for all the three depth of cut. At 150 meter per minute, cutting speed carbide sim gives preferable results as compared to the other two, right? Means at low speed, carbide seam is good. Aluminum sieve is not at all acceptable in any condition. That is the outcome. Aluminum sleeve seam material is rejected. Carbide seam at low speed, and for higher speed brass sim. These outcome is based on the dynamic motion behavior. But of course, and these all are the conclusions. Future scopes, you can change the material selections and the future scope of the variation of the spindle speed for chatter in boring operations. There are number of future scopes are available. Now I think I have 11:20 now. So now we shall open the things for the question and answer session,
Thank
right?
you, sir, for giving us a precious time and a knowledgeable lecture. Moving ahead in the event, I would ask our participants to ask their doubt, gathering the valuable lecture by quoting a quote of Indira Gandhi. The power to question is the basis of all human progress. Keeping this quote in mind, I would like to tell our participants that if they have any queries, they can raise their hands and we will unmute them so that they can ask their queries to Dr. Divyang Pandya, sir. Shreyas, can you unmute the person who has raised their hand?
Yes, I'm doing.
Thank you.
Thank you, sir.
You have nicely covered all the topics, giving all the basics and fundamentals, why chatter is occurring and how we can eliminate this.
Thank you,
So
sir.
I think we are waiting for participants' queries.
Sir.
Yes, sir, because during the lecture there are two times the raise has been hand, so I just
Yeah,
wind up
yeah.
at 11:20.
I think it is good.
Excuse me, sir. There is a question in the chat box from Dr. P. Chandrasekhar. He is asking, sir, any studies related to composite material as skim material
Composite material, yeah,
as
definitely. Yet in my team had not cover up that composite material, but that is covered in a future scope of work. Yet we had not covered up the that area. But yeah, there is a probability of a composite material as in a seam material.
Uh, Good morning. I'm Dr. Ajay. I have one I would not say very analytical question, but a general curiosity I have.
Yes, sir.
How significant is this analysis uh, when we consider this isotropic material?
Uh, of course,
Because most of the material, even if you consider wood, you will see that there is a lot of anisotropy present in the material. So, how do you handle anisotropy in such a situation
uh,
when basically the study is focused on the isotropic materials?
yeah, present model that we developed over here. In that, in first assumption, we make it very clear the homogeneous materials are considered, right, sir? So when there are the material non-linearity, the material non-linearities that we can add in this model, and we can go for the future work by adding the non material non-linearity. But that is also with the assumption. Then we can incorporate your query of considering the actual material.
Right, because the previous question was also kind of aimed at this particular aspect only. He was talking about the composites being machined, or the kind of chatter, delamination, debonding, which happens in the laminated object or laminated material. So I think there has to be some kind of modeling, mathematical modeling, where the coupled study of the laminates and the machining is done together, and then maybe we will have some solutions towards this particular problem.
Yeah, definitely. And that's what I suggested you. Na? You go with the study of a chatter non-linearity. That model is also available. And I think for production and particularly chatter topics, one can refer the site of the IIT Kanpur. On that, they are having a very good videos in that particular direction that you are asking in detail. So I think you go with that. Non-linearity we can add. Again, in mathematical model, we are having only the limitation to predefined non-linearities only, mathematical non-linearities. But in actual case, in actual material, the material, workpiece material, we cannot say by any restriction. So that is the first thing. Mathematical model is tentatively nearer, but not the exactly never for any mathematical model.
So that means there's a huge scope of work in this particular area, because
Huge.
yeah.
Right now, that's why I told you, na, known linearity in chatter, that is the newer topic. Known linearity in chatter, that is the SSD, and that what you are talking about, the coupling modeling. The people are working on that. So that is a huge scope in this particular area.
Thank you, Professor.
Yeah, welcome, sir.
If anyone has more queries, they can raise their hand.
Sir, may I talk, sir?
Yeah.
Sir, good morning, sir. I am Dr. Suresh Babu,
Yes, sir.
NEC Narsopet. May I have any information regarding aged 31 magnesium alloy castings? Magnesium alloy composites.
Magnesium alloy composites
Yes, sir.
as a sim material.
Pardon?
Magnesium alloy composite as a sim material.
Yes, sir.
Okay. Yeah, there are. See, we had not performed that things right now,
Okay.
but yes, definitely there are a number of options, because when we are presented this at IIT Bombay, so we have a comment that why don't you go with the not at IIT Bombay. We have a comment that, or a suggestion to go with the SSC material.
Okay.
So we definitely go ahead, because right now I am not having any idea.
Okay, sir.
So about the magnesium or a steel base, we are attempted,
Okay.
but other composites and all that, we just gone through the material.
Okay.
I'm not making any concluding remarks, because as we discussed, the nonlinear responses in computational study and behavior studies are all too different. So I would not like to make any comment that may misguide your future work.
Okay, sir. Thank you.
Yeah.
I think there is no more questions, so student coordinator can move ahead.
Honorable Eminent Speaker Dr. Divyang Pandya Sir and Head of Department of Mechanical Engineering, BIT SINDRI, Dr. Sanjay Kumar Sir, respected Coordinator Dr. Chaitanya Sharma Sir, and all the participants. It's my privilege to propose a vote of thanks on this occasion to Dr. Divyang Pandya Sir. I, Preeti Chaudhary, on behalf of Department of Mechanical Engineering, BIT SINDRI Dhanbad, extend a very hearty vote of thanks to Honorable Delegate Guest, Dr. Divyang Pandey, who blessed us with his presence and took out valuable time to his busy schedule. And I must mention our deep sense of appreciation for him. Thank you so much, sir, for such an enlightful session on chatter reduction process, where you explained us well about multi-degree of freedom system, dynamic motion, motion stability, turning operations, and depth of cut, etc. Through this session, we got a clear idea about the differences between vibration and chatter. Thank you so much, sir, for coming here and enlighten us with your knowledgeable lecture. Hope we will meet you soon again, sir, so that we could learn more from you. Thank you, sir. Thank you for coming.
Thank you very much. And I convey my with regards to convey. Okay. Thank you very much to all the participants and good luck to all of you. And convey my best regards to your head of the department, Dr. S.K. Singh, sir. And Dr. Chaitanya Sarma, sir. Thank you very much for organizing such a successful FDP and wish you a good luck.
Thank you, sir. This is all because of you, sir. You people are always ready to accept my invitation to deliver your talks, spare your valuable time. Otherwise, it is extremely difficult to organize faculty at such a short notice. It is just because of your generosity, sir.
Sir, it's our pleasure to associate with our all colleagues and
Yes,
IIT researchers. Thank you very much, sir. Nice
thank
talking
you,
with
sir.
all of
Thank
you.
you.
Okay, sir.
Okay, sir.
Yeah, bye-bye.
Bye, sir. I request all the participants to remain with us. Another speaker, Dr. Ashwini Sharma, Dean School of Engineering and Technology, Admas University, Kolkata, is going to join us very shortly. He will enrich our knowledge on the topic of Industry 4.0. So be there. In between, we are going to share. Sir has already joined. Welcome, sir.
Yeah, good morning, sir. Good morning.
Sir, this is unfair. You cannot call me sir. I will be your student forever.
I'm proud of you.
Thank you, sir. Thank you. We are in the novel profession in which we do not compete with our teachers or students. So I will be your student forever. And that is a great honor for me.
Thank you. Thank you so much. Thank you so much.
So student, now you can formally proceed the session. Thank you, sir, to accept and join us.
Before moving ahead, I would request all the participants to check the chat box. There is a feedback form in the chat box. You all can fill that for the first session, and after 2 minutes we will start the second. Student coordinators, you may proceed now.
Thank you, Stress. Now moving forward to our next speaker, for whom words fall short to describe such a dynamic personality that Dr. Ashwini Sharma sir is. We're trying to keep it short. Professor Dr. Ashwini Kumar Sharma is a dynamic teacher with a rich experience of 20 plus years in engineering education. Professor Sharma is doctorate from National Institute of Technology, Kurukshetra, and certified for CMI Level 5 in Management and Leadership from Chartered Management Institute, UK. He has received several awards and accolades, including Best Teacher, Gwalior Gaurav, Best Dean of the Year 2019-20, Distinguished Leader in the Engineering 2018, Engineering Excellence Award 2020, and won national design contest by 3D PLM software Dassault Systems Pune in professor category. He has been associated with national championships, example Baja Sa India, Supra Sa India, FE Cycle as faculty advisor and judge in ESVC, HVC and Go-Kart championships. He also developed innovative teaching and learning aids for engineering students. Without wasting much time, I would now ask Dr. Ashwini Sharma sir to please unmute himself and carry over this session from here onwards on his topic, Industry 4.0. Sir, please.
Yeah, thank you so much. I need permission to share the screen.
Yes, sir.
Student, there is any problem?
Yeah,
Yes, sir.
I'm asking for the permission to share the screen, sir. It is disabled. I think the previous speakers, there might be some issue. So once they
Pallavi ma'am,
permit, I
can you
will.
make Ashwini Sharma sir co-host? Pallavi ma'am, can you make Ashwini Sharma sir co-host?
Allow sir to share his screen.
Yes, sir, we are working on it.
Okay. मैं तो हूँ सर की बात कर रहा हूँ. Hello, student. Have you
Yes, sir.
permitted
sir to share the screen?
Yeah.
Yes,
yeah,
sir, now he
it is
can.
permitted.
Recording in progress.
Yeah. So is my screen?
Yes, sir. Visible, sir.
Yeah, right. Yeah, so very good morning to all the participants, the viewers into this session. I'm thankful to the organizers from BIT SINDRI who has started with this EFDP on advances in manufacturing. This is a very good initiative taken by them because in these times only when we are sitting at home, we can increase upon the knowledge in whatever way we can. So I will be starting with my presentation on Industry 4.0. So before going to that, let me just ask you some questions. Who are my audiences? Is it the students, teachers, or maybe some professionals or people from outside?
Sir, mainly the teachers. Some of them are PG and PhD students.
Okay, right.
Faculty from graduate and diploma colleges, sir, basically.
Okay, right, sir. So this is that's what I was saying, that this is a very good initiative. Let me tell you one thing. Maybe 2 years before, if we talk about, it was something like uh, okay, let me put it in this way. Teachers are the people from whom the things are expected, right? Everybody might be agreeing with this, that there are a number of stakeholders. One is our students, then their parents, then the society and whatnot. But everybody is expecting from us that if he is a teacher, he knows everything, and there is no issue in asking of any help from his side. But very few people like Professor Chaitanya Sharma think of something like this, where teachers can be imparted with the latest know-how, because this is something which is to be gained by the teachers every time, to be updated as per the need of the market. And in that, I congratulate the BIT Sindri for taking up this initiative. And to start with, I will be deliberating on Industry 4.0, which is again a new buzzword which is into the market. Many of you might have heard of it. So I will be taking I will be taking you through the journey of Industry 4.0 with some of the practical aspects of it, how it is changing the world nowadays, right? So this will be the simple content of my presentation. Okay. So, and from the coming slides, we will be covering all these topics. So this is something which many of you might be knowing. So the question is, what is this? It's not a shivling, for your information. The people who used to be in village or who have seen the villages, they might have understood what is this. It is to grind the wheat and then make it a flour, right?
Yes.
Atta ki chakki,
Yes, sir.
ancient type. Nowadays, I don't know whether it is available in the villages or not, but you will find in most of the households in the villages. So this is something which is primitive, right? Again, it's a machine. It's a machine. Now, this is another thing which is again a machine, but primitive type, and this is something, water is flowing. There is, so all the people are from maybe the mechanical engineers, they might be understanding that this wheel might be rotating and something might be happening inside the hut or home. So that something might be the same floor mill what we have seen in this primitive term. This might have been mechanized with the help of this process, in which the human effort could be very less. Now, if you want to witness this, you will not be able to see this anywhere. I have gone to a number of places. If you want to witness this, please go to Palampur, then it's in Himachal Pradesh, right? And it's the place where right now Dalai Lama is there. So MacLeod is the place where you can see this thing in running. Still, they are using this for making the wheat flour. Okay, so what we are seeing now, by this slide, you might have understood what is going on. We have gone to the primitive, then another mechanization, and this is where this thing is converted into something which is semi-automatic type, where the motor is grinding something which we are putting into the hopper, right? And we are getting the output from this. So this is again the flour mill, right? And coming next to it, it is, oh my God, so this is something big, okay? So you can consider that it is a factory, or it is a setup where the floor mill is there, and they might be making a brand of atta. That means it may be Ashirwad or Fortune or whatever. There are so many players in the market now. So what we have seen till now is number of devices or equipment, basically, which are used for the same purpose but at the different times. So if you see the initial one, you might be using that 50 years before, but this thing what you are seeing in front of your screen, maybe this is a present market situation where the atta what you are getting from online shopping, somebody might be doing this for making good money as well as a brand. Fine. So what we have seen previously, it's this. So let us talk about these revolutions, industrial evolution, how it has happened. Industry 1.0 was this mechanization, steam power, and the application was weaving loom, or maybe the slaughterhouse, which was opened in USA in 1784. Industry 2.0 considers mass production, assembly line, electrical energy aspects of it. So you can think of 1870 as the production of cars when they started with the manufacturing of Ford T model, or maybe it's the model which is basically adopted by or invented by McDonald, right? Now, coming on to Industry 3.0, that is more or less into automation, computers and electronics. Started in 1970s or so, wherein most of the production was semi-automatic. And nowadays, in today's environment, all these things coming together with the cyber physical systems. We will see all these things later on in coming slides. Internet of Things, the networking. So this is how the industry has evolved over last so many decades, and that's where we are right now. And there, in future, nobody knows what is going to happen, right? So this is what you can say yesterday's or today's factories are. Rigidly sequenced car manufacture on a production line. So if you can see that Ford model, which was maybe 100 years before, it was like workstations are there in a line, and there is something being done onto the product at different workstations, and finally the product was shipped out. And now coming on to tomorrow's factory, decoupled, fully flexible and highly integrated manufacturing systems. So here the workstations are arranged according to the requirement or according to the processes which are to be done onto the product in a very efficient way. So by this slide, you might have understood why you have, or if the students are there from the engineering, every student goes through with this workshop technology or manufacturing processes, that subject, and they study the kind of production system. So layout, line layout, then process layout and mix layout, all these things are there. See, basically it is the same. The only thing, automation is something new in these areas. So previously what we have seen, the line layout, and this one is the process layout, where the machines or the process is at the center. Okay, so next we are moving on to the promise of digitalization. We have seen a lot of digitalization which has gone into the market. Let us see what is it. Okay, so in Germany, they are saying that if digitalization is done in manufacturing or services, then it is known as Industry 4.0. This industry is not with Y, it is with IE. So that's a German term, right? And that's what they are referring to it as Industry 4.0. why it is needed. So let us see. New product must be brought into the market in ever short time frames. So here we can take an example of maybe your mobile phone. Initially, when we used to buy the mobile phones, it was for a time duration of at least 3, 4, 5 years, right? In our times, I'm talking about. But today, if you buy a mobile, it may not be having a lifespan of maybe 1 year or 1.5 years. After that, you lose interest in that. And that's what our typical psychology is. So we want something new every time. So if you are going to buy a pen, if you are not having the heart into that pen, heart means if you don't like that pen very much, then obviously you are going to try different pens once you go for buying those, so that your psychological needs can be satisfied. And this happens with all kind of products what you are going for. I'm not talking about the brands where the brand loyalty makes you buy the products and from the same company, but still my opinion here is you don't buy the same product, you buy the upgraded product, right? So let's say the companies has grabbed this opportunity to play with the mind of people. They are manufacturing the cars or bikes, and maybe 1 year after they are coming up with the facelift version of it, right? Facelift version. So what they are doing, they are changing some of the features and outlook of the vehicle, and then they are showing that into the market as something new. But the core part of it, engine, transmissions, and all remains the same. And we satisfy our need of having a new product, right? Fine. So now coming on to the demand part of it, consumer demand are the consumers demand the product that satisfy their specific need. So this is actually talking about customization, that you don't want some of the features into the product what you are buying, or you want to add upon some of the products which may satisfy your needs. So this is another area where companies are making huge business in today's scenario. Wow, this is something good. Rapidly changing market is calling for a growing level of flexibility. So if, let's say, in the previous time you are making the same model, like we can take example of car Ambassador. Yeah, Ambassador was the car, right? It's not now, it is not available, or if it is available, it is like an antique piece. So what they did not change according to the market needs, or they were not flexible. It was like a production line in which the cars of the same model are being produced. It has created the brand, and then after that brand fallen down. So we need to take care in today's scenario, the rapidly changing market needs. Okay, so next part is a constant desire for increasing efficiency that requires shorter and shorter development time and efficient use of resources and energy. So shorter development time means we have to rapidly come into the market so that we can have more of the market share and we can make a very good business out of it. So in that area, we need to increase upon the efficiency, the productivity, development time should be reduced, and we need to utilize the resources, man, material, machine, or other commodities or utilities in very, very efficient way. Energy being one of that aspect which is required by all the industries. So if we are reducing that, obviously cost of production is going to be reduced. So we know that. This is again another thing. You see how the things are being squeezed. As an engineer, we need to cater to all kind of these demands which are being which are done by the customer. So all with no loss of quality. Means you cannot compromise on the quality, or you have to improve upon the quality, right? In some of the cases. So if this is kind of scenario of the market, which every one of us knows that yes, it is going on. So how to cater to this kind of requirement? And that is the promise of digitalization, where the efficiency increased, increment or forecasting accuracy and specific need customization, and there are a number of other tools which are available to design the product in a very efficient way. Fine. So let's see what the digital enterprise looks like. Okay. So what happens in digital enterprise is entire value chain is digitized, is digital and integrated also. So initially it used to be silos, means one department is working on something like R&D department, then marketing department, maybe production department. They may not be having those kind of communications, or every time they used to put it onto the drawing sheet, where if the connection and thoughts are not being exchanged, then you are working in silos. But digital world has shattered all kind of these boundaries. So digital world starts from the product design. So if any of the mechanical engineering student or faculty is there, they might be understanding that yes, product design is not as usual onto the drawing boards and by the drafters. It's on the computers now, using different softwares, doing design, then analyzing that, and then finally creating finally generating the drawing of it. And the same way, everything is computerized. Production planning is also a kind of Herculean task nowadays, because you have to produce less quantity in a very short duration, and then another time again you have to change the product, or you have to improve upon the product. So you cannot be working on the product for maybe years. It may be months now. Then coming on to the production engineering, where you need to define the process or how to produce the things. Then actual production happens, and that happens with the kind of today's machines, which are called as CNC machines, right? Those are connected machines. And then finally coming on to the services part of it, again those are connected, and finally it goes to the real world, that means to the consumers. So in this, you have to manage everything with shorter life cycle time. So in that case, it is very, very important that we digitalize it so that efficiency is good enough. So till now, if there is any question, please ask. Or we are going to take question at last?
Yes, sir, we would be taking it at the last.
Okay, fine. So now coming on to the same term, Industry 4.0, which will be coming for many times into this presentation. So just see it here, what is happening. So first one is aware. Smart products are equipped with sensor technology. So how do we aware? We have got 5 senses by which our brain processes the information and then takes the necessary action. So all kind of sensors are provided or are installed in order to access the condition information of some system, right? Regarding the product and its environment. Now, what is another thing? That is connection. So all smart products I am talking about are equipped with machine-to-machine communication devices that enables interaction and data exchange with other cyber physical systems. So this might be looking as a jargon, but we will be seeing this cyber physical system in coming slides. Okay. Then the system, the system which is Industry 4.0 system should be very responsive. So smart products are equipped with control technology that enables autonomous product adoption based on internal or external commands. So sometimes what is internal command? Internal command is maybe putting up some program into the system so that it automatically calculates the things and takes the necessary action. Or sometimes it is from our side where we are giving the command. Then the system should be intelligent also. So these products are equipped with computing power that enables autonomous decision making and self-learning process based on defined algorithms. So we consider in advance that how the product will be used or how the user is going to behave with the product. So in that way, we can put the intelligence into it. A very good example of this might be the washing machine. Yeah. So washing machine previous times, then it came out as semi-automatic, and now it has come out as automatic. So how does this machine knows? The washing machine knows that this time, this is the time duration for which I have to roll the cloths or the garments inside the machine, and after that this much water is needed, and then this much is the drying time. All these things are considered in advance to design the product, right? So this is how the industry 4.0 works out. So this gives some kind of understanding how it happens. Now this term is smart manufacturing is nothing but industry 4.0, right? So do not get confused. So smart manufacturing, it depends on you which term you want to use. So this is a collective term for technologies and concepts of value chain organization. Value chain means right from the beginning to the end. We will see this value chain in coming slides, how it looks like in the organization based on the technological concepts of three. One, cyber physical systems, the IoT, and Internet of Services. Now this might be a new word for you, Internet of Services. So this is now being used extensively by the service industry, and this all facilitates the vision of smart factory. Okay, now this is under the modular structure. Cyber physical system monitor physical processes, computerized systems, create a virtual copy of physical world, and make decentralized decisions. So now this virtual copy, what is this virtual copy? We will again see by the example, but just to tell you, nowadays we have come across with the technologies where whatever machine is running physically into some environment, the same machine is available to us in front of us in electronic form. And this term is also known as digital twin. So whatever parameters are working there in a physical environment, the same parameters are being shown to you, and you can play on these parameters so that you can change the process outcomes within no time. Okay, over the IoT, cyber physical system communicate and cooperate with each other and human in real time. So cyber physical system now is defined that it is also taking into consideration humans. That means humans are interacting with some kind of system, and that is called as cyber physical system. Via the Internet of Services, both internal and cross-organizational services are offered and utilized by participants of the value chain. Again, the word has come. So let's say somebody is manufacturing the bike, okay? Or somebody is manufacturing the mobile, because mobile is with everybody nowadays. Smartphone I'm talking about. This mobile phone is manufactured into the factory and then it is shipped to the customer and we are using it. Maybe the company might have connection with your mobile set in terms of how your mobile is behaving. So let's say if you are using the mobile in Himachal Pradesh in very, very cold environment, or in Rajasthan, hot environment, or maybe some place where it is the humid environment. So all the parameters by which the mobile is operating, the people inside the company, they might be knowing that how their product is behaving. I'm taking the example of mobile, which may not be a relevant example, just for understanding, but there are machines, big machines, which needs to be maintained frequently, like automatic harvester of John Deere, automatic crop harvester of John Deere. You don't have to sit into that vehicle. If you want to sit, that will be a manual operation. Still, it will be connected to the operant organization which has manufactured that. And then they are coming to know what are the different parameters going on with the product what they have supplied and taking the necessary action as and when needed. So coming on to the building blocks of Industry 4.0, you are seeing all these things are there: autonomous robots, then the simulation, very important, horizontal and vertical system integration, industrial internet of things, cyber security. Security is very important, otherwise somebody else might be digging into your system and will come and maybe tamper with that. Then comes the additive manufacturing, which is nothing but the 3D printing, augmented and virtual reality. This is another big thing which is happening with the market, and in times to come, within next 5 years, the entire industry is going to change. It has already changed. This augmented reality and virtual reality has already changed the gaming and animation industry. Big data analytics is very, very useful at the time when you are producing the product which is generating huge data. So what can be the example of this big data analytics? For us, it might be aviation industry. Yeah. So when the plane is taking off, there are so many things which are working there. And if this plane is connected to the parent organization, that's the fabulous thing which can happen, because they might be knowing how the parameters are defaulting into the plane, and then they are taking the corrective action. So this data which is generated by plane every second is very huge data, and for that we need to have the analytics. So this comprises the Industry 4.0. These are some of the technologies which are there. End-to-end process management is one area where starting from the end and starting to the end, the process needs to be managed. Initially, it was the human intervention, and then it went on to the semi-automatic and finally fully automatic kind of system in today's factories. Smart autonomous assets. Smart autonomous assets are the right now we are using it for delivery in foreign countries where something, if it is being supplied to a household in online shopping mode, then without a human intervention, these things are supplied and the people are collecting it. 3D printing and virtualization, digital workflows and platforms, because it is not only manufacturing, it is the back-end process also. There are so many processes which are involved in that: data collection, then analyzing the data, then coming up with the decision making that yes, we are going to make this product. These are the different changes we need to do. So if, let's say, you are changing something into the car or your bike, the digital workflow should reach to that end, which we generally do not consider. It's the booklet which is coming with your bike or car. Yes, that also needs to be changed. And if that is to be changed, it is a Herculean task, a hell lot of difficult task. So if you have that digital kind of workflows, everything will be changed and you don't have to worry about that. Then human interaction is one thing. Then big data we have seen, and the new digital business models are evolving out of it day by day. These are the design principles of Industry 4.0. Ability of cyber physical systems, human and smart factories to connect and communicate with each other. So everybody is communicating with each other via IoT and Internet of Services. Virtualization is nothing but digital twin, which I talked about. Nowadays, maybe somebody who is okay, fine. So let me give you one example of this virtualization. Recently, I have met one of my very good friend. He is working with the company which deals with the renewable energy, right? And they are into windmills. So what he was saying that, sir, we are having our engineer here in India, and this person is maintaining the windmill which is there in Australia. Okay, so how does that happen? There is a virtual copy or digital twin of that windmill which is available to his disposal, and every time he is checking the different parameters of windmill, how it is behaving. Then decentralization, cyber physical system with the smart factories to make decisions on their own. So initially we used to make the decision when it was a manual system. Now all the decisions which are of less importance or which can be automated, they can be taken care by the cyber physical system itself. Real-time capability is to collect and analyze the data and provide insights immediately. That means it should happen now, not after 5 minutes or 10 minutes. In real time, it should go on so that you can take the corrective actions if something goes wrong. Service orientation, offering services via Internet of Things. So as I told you, the example of John Deere was taken. So this is how the companies are doing. They are not only manufacturing the products, they are also giving the services after sales. Okay, next is modularity, flexible adaptation of smart factories for changing requirements of individual modules. Whenever you are coming up with a new product, and if it is a line on which that product line with the number of workstations on which the product needs to be manufactured, if you are changing the product, if you are coming up with a new product, obviously this line needs to be changed. So that's how it is talking about modularity, that within no time you need to be up with production of next new product which is going to be launched into the market. So these are the 6 design principles of Industry 4.0. Very simple. Now coming on to the cyber physical system, it is having computation or digital things, then the control part of it, and then communication. Everything happens to be the information, and information is the key. So it's a system of collaborating computational elements controlling physical entities. So computational elements means your computer is actually controlling something physical, maybe a machine, maybe a system, maybe a factory. So it's named as CPS as abbreviation. Operations are monitored, coordinated, controlled, and integrated. Now these are the 4 functions which are done in real time, which is very difficult if we go on the manual basis. They also allow us to add capabilities by merging computing and communication with the physical process. So now the system has become very complicated, merging computing and communication with the physical processes. So obviously this can only be possible with the help of highly efficient systems, computing systems. Fine, so let us see what did not exist in 2006. Some of you might have already seen this slide somewhere, because I have also taken it as a reference from some other source. So iPhone was not there in 2006. And this is how the market is changing. See, all these are the new products which has come into the market, and we might not have thought of it. iPad, Kindle was not there. We used to read the books. Still we do that. It's a good thing. 4G, yeah, it was not in 2006. Uber, virtual, Airbnb, Android, Oculus, Instagram. Now this is something interesting. Instagram, Snapchat, and WhatsApp. Think of it. It's a magic. It's 2006. These things were not there, and today it's just like a usual thing for every one of us. This is time to reach 100 million of customers. See why I am telling you so, because the change in market happened like this. Telephone took 75 years to cross 100 million users. World Wide Web, 7 years. Facebook, 4 years. And if you want to know more about this Facebook thing, please watch a movie that is called as The Social Network. It's a story of Facebook only. And in that very clearly they have shown, very beautifully they have shown how they have reached this 100 million customers. So it's a kind of excitement every time when they are reaching to, let's say, 100 or 1,000 or 1 million or so on and so forth. It's a beautiful story. you must, at least you must watch for once. Instagram took only 2 years, 1 month. And there are other things also. A good example of that is very rapid crossing 100 million customers or users, viral videos. So if some video is viral, it is moving into the market like speed of maybe a rocket or a spaceship. Fine. So now let us see what are the potential implications. What can be the futuristic things which will happen, or what is happening present in the present scenario also. So it will be having implications on robot assisted production. We are already started seeing that. If you might have visited some plant, good plant, then you might have seen this thing. Predictive maintenance is one of the most important thing which is happening nowadays. Additive manufacturing of complex parts. Now we are going for the metal parts also. Machines as services. Machines as services, you can consider that vending machines you might have seen, automatic vending machines. So if you are putting up, if you are showing the card, then this machine is asking you on the LCD panel that what you want, and then you are clicking on it, and finally it is delivering something, and nobody is there to check on that. And this machine is connected through internet to the parent company, where the company people knows that this is the product which has gone out of the machine, so we need to replenish that. And that's how the machines as services are there. Big data to derive the quality control. So quality can be maintained with the help of having the huge data, and then we can come to know in this year or this point or this second, whatever the product was produced was not good with the quality, or is not good with the quality if it's a real-time scenario. Then production line simulation, that is nothing but the digital twin and smart supply network. These are the potential implications of Industry 4.0, but not limited to. So we will be seeing some of the examples of it. So this is what I was talking about at the time when we have completed with the theory part of it. Okay. So let's see what are the different things which are there with the Industry 4.0. Fine. So Siemens in a big way getting into this area of Industry 4.0 or smart kind of things. Now what they have done, artificial knee and hip joints were standardized products with engineers needing several days to customize them for the patient. Now new software and steering solutions enable Siemens to produce an implant within 3 to 4 hours. So let's say if it is knee implant, obviously our anatomy, human body anatomy is different for different people. So somebody is short, somebody is taller, somebody is fat, somebody is thin. Based on that, the knee implant or kind of implants which needs to be there for the body, these are differing. Means it differs from person to person. So variability is huge variability. We cannot imagine that. So if we need to customize according to the requirement of the person, these implants, then initially it was the standardized product by which your body may or may not be able to adopt the implant. But nowadays you can customize it within no time with the softwares, and your implant is ready within 3 to 4 hours. So what they do, they design it on the computer aided design system, then they analyze it, and according to requirement of the customer, they fulfill all the requirements, and then finally once they are through with that, they are putting it onto the 3D printing. And from 3D printing, they are taking out the finished product which does not need any further finishing of it. So this is a beauty which is there. German tool maker, they came up with the concept of social machines, in which each component is smart. Smart means connected. Smart means connected, and knows what work has already been carried out on it. So let's say if your mobile is giving you an indication of how many times your battery cycle has gone. Battery cycle has gone means how many cycles it has completed. What is the health of your battery in the mobile phone? So for that, your battery needs to be smart. The battery needs to be connected. All the parameters with the battery should be known to the system, and then system decides and reflects onto your screen that this is your health of the battery. Generally, it happens with the kind of high-end laptops where you can check the health of the system, right? Some of you might have done that. HP has done that. So it's not only battery; it's all the components which are coming up with coming in the laptop. You can find out the health of that, and that's what a smart component means. Okay, so because the production facility already knows its capacity utilization and communicates with other facilities, production options are automatically optimized. Now this is coming as an optimization part of it. It is reaching to the best one, reaching to the best possible alternative or solution. Okay, so let's go for this practical implication of it as maintenance management, which is a broader term. So real-time monitoring of physical assets allow determining when a measurement is out of range, and it is necessary to perform CBM or even applying AI or machine learning or deep learning to predict failure before it happens. So let us consider a situation wherein a turbine which is there with the power plant, it is running 365 days 24/7, yeah, and it's actually performing its operation sitting on two bearings on two sides of it, just a simple setup. Now these bearings, you know the turbine speed, how much that is, and then we have the reduction gear, and then that's how we are generating the electricity. But if the speed of turbine is that, then we need to know how our bearings are performing or how the lubrication in the bearing is performing. And that's where your bearing should be smart. The bearing itself will give you a kind of indication or signal. Yes, I am into this situation. Let's see. Is the sound audible to all?
Yes, sir.
Okay.
Oh no, sir, video sound is not audible.
Yeah, video sound is not coming, right?
Yes, sir, not coming.
So just a second, how to?
So while sharing, you need to enable the device sound.
Just a
Computer
second,
sound.
I have checked this. Yeah, just a second. Let
costs and higher productivity.
Yes, sir, now it is audible.
Now it is coming, sir.
Okay, sir. Okay, sir. Thank you.
Civilization, mankind has always strived to grow and learn, to invent and innovate. Even today, business firms across industries seek to attain better performance, lower costs, and higher productivity. However, unanticipated machinery failures have resulted in extra costs, time delays, and numerous losses. This problem persists across all industries. Without preventative approach, enterprises are unable to optimize their operations. Further, siloed and disparate resources, limited spare parts, and lack of skilled engineers has left things unresolved, which calls for a comprehensive solution. HCL IoT Works Predictive Maintenance Solution is an IoT-enabled monitoring and maintenance solution that provides visibility to the imminent failure of any pivotal component of the machinery by using different types of data from the asset, using deep learning algorithms to predict a probable breakdown. It amalgamates things, data, processes, and people, by providing measurable business outcomes for better analytics and behavior prediction. The predictive maintenance solution lights up an important, expensive business asset and continuously integrates multiple types of data onto an IoT platform. The system analyzes data using algorithms, which results in increased reliability and control over equipment life. The analyzed data details usage patterns and product life cycles. If a component is in critical zone, the system recommends steps to optimize, thus smoothing the maintenance process for minimal cost. An intensive care design thinking approach has been used to craft user experience and interfaces, making the entire process easily accessible. Moreover, the system allocates enough time to accommodate a local professional before the equipment fails. Workforce productivity increases by more than 50%. The system connects the various components and systems of an enterprise onto a single platform. The predictive maintenance is a ubiquitous solution having applications across every industry that uses heavy or expensive machinery, saving resources, money, and time. Welcome to the future. Say hello to HCL IoT Works Predictive Maintenance Solution. For more details, contact our...
Okay, so it's not for HCL because we have got number of other industries to go for. We have seen just a glimpse of it. So Predix is another thing which has come into the market in a huge way. Operating system for industrial internet is powering digital industrial business that drives the global economy by connecting industrial equipment. Now see, connection is happening here, analyzing data and delivering real-time insights. Predix-based apps are unleashing new level of performance of both. Who is that? General Electric. Okay, so let's see how General Electric is doing that.
There's great power in what if. What if you could anticipate problems before they occur? What if you could reduce unplanned downtime? What if every machine, all your equipment, was performing at optimal levels safely and securely? What would that look like? Welcome to GE's Asset Performance Management suite of solutions powered by Predix. GE's cloud platform purpose-built for the unique volume and velocity of industrial data and analytics. Here's how GE APM works. To get started, just get connected. Capture and manage data to gain a more complete and accurate view of your equipment and machines. This first step of the journey monitors machine and equipment health. Next, use advanced analytics to get insights, predict and diagnose issues early, and respond before failure. And these insights can help you make better decisions. This phase is called reliability management. Then,
okay, so just see onto the computer, you are seeing that turbine, okay? And all kind of controls which are actually with the physical system are shown here. So basically you are controlling it from here, and this is called as that digital twin. Somebody has raised the hand, I think.
So we will take questions at the last step of the
Okay, right.
get optimized. Create maintenance strategies that balance reliability, performance, and costs. This is maintenance optimization. GE's Asset Performance Management gives you the tools to get the most value from your industrial scale data and get the right information in the right hands at the right time. Across industries, our customers are seeing results. From oil and gas companies using real-time online condition monitoring to help them avoid potential incidents, to manufacturers consolidating operating data to smooth out process variation, to utilities that are using big data to reduce maintenance costs. Industry leaders face increasingly complex business challenges. You need a partner with industrial experience, deep domain knowledge, and a long history.
Okay, again, it is not I'm vouching on GE, right? Let's go for one more. Okay, so this is another example for maintenance management. Okay, now we are going for some of the smart products. What are these? Some of you might be knowing this. There is a bulb which is available in the market, which intensity of light you can actually control with the help of your mobile phone. Okay, there is an app. So this is somewhat costly, but it's beautiful. And you can also have this from the same bulb. You can also have the kind of blinking disco light, so you can convert your room into the discotheque. Okay, digital blood glucometer connects wirelessly to a monitoring and display device that can alert patient to trends in glucose level requiring attention. So these are nowadays, these are the things which are coming as wearables. Okay. Ralph Lauren Polo Tech t-shirt, Polo Tech shirt available in 2015 streams distance covered, calories burned, movement intensity, heart rate, and other data to the wearer's mobile device. So this is again wearable technology, but right now it is in nascent phase. It's not that developed. Babolat is a Play Pure Drive product system, ports sensors and connectivity in the tennis racket handle, allowing users to track and analyze ball speed, spin, and impact location to improve their game. So basically it is getting into everything. Now, if you want to manufacture these kind of products, obviously human intervention should be minimum, and most of the time you need to have the machines which can produce these kind of smart products. Okay, next part is the smart buildings. So nowadays these are very high in demand because of the energy requirement. And if you see it here, AC power needs to be reduced, so your building should be designed in that way, and that's where comes the civil engineers into picture, gas water submeter, temperature, humidity, outdoor temperature, relay nodes, routers. But not limited to this, we need to have the security arrangement, we need to have the protocol, who can enter into the building, who cannot. And if you want to see that, you just go to any of the building in Cyber Hub in Gurgaon, and you will find all these things actually working there. And say you need to put up your card in order to access a particular location, and it will deny your entry if you are not authorized for that. And that means the proper system is working behind that building in the background, so that the security is also being checked upon. Apart from that, building health and all kind of sensors are installed into the building, so that building behaves as a smart building. Okay. So this is again from
We spend 90% of our lives in buildings. Shouldn't they be perfect places to live, learn, heal, grow, or innovate? Buildings can be smart, like driverless cars, planes that fly themselves, or our smartphones that control home lighting, heating, and security systems. But will a building continually run analytics to detect equipment failures before they happen? Or anticipate security needs based on trends and predictive movements of its occupants? Or create smart spaces where shades adjust when the sun is shining directly in the windows? Today, buildings produce thousands upon thousands of data points each day, which literally creates a pool full of data. But in fact, the most important and useful data would fill only a cup. Just have to know which cup is most important. Tomorrow's buildings will be autonomous. They will always be learning, always be awake 24/7, days, nights, holidays, and weekends. They will continuously adjust based on the current environment and requirements. And autonomous buildings will let your occupants focus on what they are passionate about. Just watch what your building might uncover using deep machine learning and artificial intelligence.
Interesting. The power this fan is using seems a little high. We may be using electricity we don't need. Confirmed. The power consumption has been increasing steadily recently. Checking the environment. The supply temperature and static pressure are within acceptable range of set point. Fan output is at 76%. All appears to be normal, but the fan output is definitely higher than usual. Checking service records. 10 months ago, the fan belt was tightened. Here is the part number and life expectancy. I see it was last replaced 5.5 years ago, and have identified the runtime of the air handler. Based on this intelligence, the belt has exceeded the normal runtime, and is probably slipping. This is serious. The fan is in one of our most critical building spaces, and any downtime will cost us much more than the price of the belt. There is not a belt in our inventory. Ordering replacement. And I have notified our facility engineering department with all the necessary intelligence.
As you can see, autonomous buildings learn. And the more they learn, the more autonomous they become, changing from strictly a cost to an asset. This will allow building owners and their staff to spend less time and resources running buildings and more time on what's important, the occupants. Siemens can help you create the perfect place.
Good night.
Siemens.
I hope some of you are not slept because she said good night to all of us. It was in the video. Okay. So this was a typical example of smart building. We have only taken this air handling unit. Now you might have a question that why it is needed to maintain that air handling unit. What is the big thing about it? We used to have the air handling unit malfunctioning and all these things, but nowadays, being a customer, let's say if you are going into a hotel where you are renting a room, maybe around 2,500 rupees. Now, at that time, if that air handling unit is malfunctioning and you are not having that proper air supply, then what you feel? You feel cheated, right? And next time you will not come to the hotel. So basically, there will be a loss for the business to the hotel manager as well as number of other people who are associated with that hotel. Maybe the vendors, you might be eating food there, you might be staying there for maybe 7 days in a year, and likewise thousands of customers in a year. So because of this malfunctioning, which is a typical case, people lose business or businesses lose business. So that's where the importance comes. Now coming on to the smart factory, we have got a number of things which are associated with that. Customers, then distribution center, we have got the smart grid by which the energy is being supplied, and energy is being supplied in a proper format. That means as and when it is needed, it is supplied. Then comes the supply chain part of it, where you are getting the raw material or some kind of sub-assemblies to put into the product and to be assembled here into the factory. And then comes the business ERP system, where entire information is being captured and being delivered at the right node. So a smart factory is dynamic plant configuration readiness, dynamic product configuration, and inventory minimization. So nowadays these factories are no more static. They have got everything dynamic into them. And that's where the optimization part is very, very, very difficult. And that's where we need to have the smart factories. Okay, so a smart grids meter equipped with the sensor and better monitoring and control needs to be done in the electrical network. Information in this case is very, very high value as far as the consumption is concerned, offering valuable information to the end user. So if you have the smart meter, not the usual smart meter, the smart meters are actually giving you entire information on a particular day, how many units you have consumed, and in a particular time, what was the kilowatt you were using. So these kind of information actually offers the consumer to use the energy in a proper format, proper way, so that the bill or the cost incurred is less. And that's what the one thing. And second thing is, on to the upper side of it, if you see the people from the electricity department, they can also come to know what kind of consumption is or patterns are being there.
Our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HAN, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago many miles away. In each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the...
So what we have seen here is the generation, distribution, and utilization of one area, that is energy. Likewise into manufacturing, likewise into some different other areas, we can implement these technologies, which are connected technologies. Okay, now coming on to the robot assisted production, just see this one. You will be able to understand better with this.
Normally when you come to CES and it's lunchtime, you're going to walk over to a food truck and maybe you're lucky to get a burger or some barbecue or something. It's all pretty heavy stuff. So when I walked into the Samsung booth and was given the opportunity, or should I say, when I begged for the opportunity to eat a salad made by a robot, you better believe I jumped on it. Let's take a closer look. Now, Bot Chef is what Samsung likes to call a cobot, or a collaborative robot. That means it's not meant to do everything for you in the kitchen. It's not going to saute stuff and prep everything. It's meant to be worked alongside with. You as the user in this sort of utopian, ideal smart home situation, you'll be able to ask it to download recipes, get through some of the prep work. It'll be able to download skills that it might not have as well. We saw a demo of the bot chef downloading the understanding to operate an espresso machine, which, sure, yeah, I'll take that. I don't think that's going to be a thing for quite some time, but it's nice to know Samsung is, their head's really in the game here. It was really cool though seeing these two discrete metal robot arms picking up a tiny cleaver and very delicately dicing a block of tofu. And then once that tofu was moved into a frying pan, which was non-functional because Samsung couldn't get the permits, another arm picked up a spatula and just sort of moved it around the frying pan as though it was trying to saute these things. And they would have been had they had some fire going on under these things. I gotta tell you, the level of nuance these robot arms are capable of is pretty impressive too. We saw it opening cupboards, removing ingredients. There are several cameras in the mix as well, so if it can't find an ingredient, you place it on the counter in front of it, it will identify it and use that ingredient correctly. There's a lot of stuff at play here. There's a lot of really interesting sort of machine learning going on under the hood, and while Samsung really wasn't in a position to share a ton about how people's homes, they've said that they've committed to making them, quote, affordable, unquote. I don't know what that means at this point, and I'm fairly sure they don't either, but you heard it here. They want this thing to be more or less accessible to regular people. There is no official launch date for this kind of thing. It too, sort of like Bali, is...
Okay, I hope I have got some more time to deliberate.
Yeah, sir, you can.
Yeah, thank you. Thank you.
Kind of in the concept stage, but it does seem to work. Everything does seem to work more or less okay. Oh, and that salad that it helped to make, it's actually pretty good. The vinaigrette could have been a little bit better, and I think a little texture would have been nice in sesame way.
So it has gone to the food also, and this is almost 12:45, so people might be hungry. Anyway, I just have some 10 minutes more to go. So this system, what we have seen just now, this is called as real cyber physical system, where the human intervention is also there to program the robot, to train the robot, and then to serve the people in a more congenial way, where these people are delighted to have it from your side, right? So this is it. Now coming on to the mobile manipulators, let's take an example of mobile phones only. For mobile manipulator, mobile industry is having 37% mobile plants, then 38% are into adapters, 19% battery, 6% are into some wired headset and USB cable, machine mechanics, all these kind of things, right? So in last year, the entire sale of mobile phone in Indian market was 53 million, considering that there are 300 companies in India operating with the mobile kind of business. So if we divide the share amongst all the companies, because it's not good, but just for your understanding, I have divided it equally. And one company is manufacturing in every day 4,840 mobiles. With human intervention or manual operations, it may not be possible. So that's why the people are going for it. Not only that, because we are not manufacturing only one mobile set for maybe 5 years. We are actually manufacturing mobile set maybe for maybe 2 months, and then again stopping the line, coming up with a new variant of it, and then manufacturing again for 2 months, and then comes the new mobile phone, which has got altogether a different kind of a specification. So we need to comply with that, and that is why the modular kind of factories are needed, which can adapt to the manufacturing of product within no time, and they are ready for the production of the product. So this is the robot which is for mobile manipulating kind of thing. So this is testing going on here, how it performs. The operation is pick and place. So this is basically a simulation testing of the pick and place operation by this robot in Waypoint. It's a mobile manipulator that has got wheels as well as it has also got the manipulator. So one of the application in pick place maybe into the industry where you are replenishing the tray which is holding the components for assembly into a car or maybe bike by the operator. So you don't have somebody to employ for this, and this robot can 24/7 work on that aspects of it. And this is something which is beautiful. There is a good story about it. Okay, so this is a heavy-duty robot by Boston Dynamics for warehouse management. Again, pick and place of operation. Yeah. See the statistics. Only with the Amazon, it's 2016. I'm talking about 45,000 robots were working in one way or other, small and big, to manage the warehouses all across the world. So that's how you can imagine what kind of market these robots are having. Now coming on to this one.
Hello everyone, I'm a sorting robot. I know I look cute, but my skills are a lot more impressive. I can identify the information on each of the parcels effectively and sort them out precisely. My friends and I can process as many as 18,000 parcels in an hour.
This is a 1.3 square kilometer transit warehouse. The use of sorting robots improves efficiency, accuracy, and security during the sorting process, and also reduces manual labor costs by an astonishing 70%. This AI and logistics model is now revolutionizing the express delivery industry across the country. Between 2012 and 2016, online retail sales in China skyrocketed from 1.3 trillion to 5.2 trillion yuan, making the country the world's largest online retailer. With a flourishing development of online shopping, the express business is also booming. There are now around 8,000 express delivery companies in China, and more than 2 million people working in the logistics industry. Last year, more than 31.28 billion parcels were delivered in the country, accounting for 40% of the world's total. Revenue from the express business has reached 400 billion yuan, while the per capita usage in China was approximately 23 deliveries per year. With the recent rise of AI and big data, the concept of smart logistics has been put into service. Drones and unmanned vehicles are delivering items faster than ever before as China's logistics sector prepares to enter the smart era.
Okay, so this is what the impact of it on economy, society, business, individual, and national and global impact. I think this can be understood or self-explanatory. Impacting all the value, all aspects of value chain, we'll see that. Then coming on to this value chain, I was talking about, we will see that in the coming slides. So all kind of functions, right from the beginning to end, happens to be integrated, and that's how the value is created out of it, and that's where comes the supply chain into picture. So now today's market is experiencing high mix, low volume manufacturing. The parts, the components or the products are low in number, but mix is high, customization is very high. To save on cost, supply chain management is very, very vital. Procurement, it involves procurement, inventory, assembly, logistics, transportation, and sale. Everything is encompassed into it. And that's where comes the upstream and downstream. Procurement means onto the raw material side, it is upstream, then manufacturing, then inventory, assembly, logistic, transport, and sales. Sales happens to be the bottommost part of it, which we call it as downstream. So in the entire value chain or entire supply chain, if we put up this kind of automation by putting up the sensors and barcodes, it increases efficiency very simply. And this is how it looks like. Industry 4.0 supply chain. Now Industry 5.0 is also into picture now. People are researching on that. So raw material is there, logistics, manufacturer is manufacturing the thing, then comes the logistics again, and then the customers, then again logistics, and then goes to the end user. And everything is controlled in a seamless way by the supply chain tower. It is not a tower, it is something like a system which is in place, which is connected to all these entities. So let us just see this one.
The supply chain is drastically changing. With the increase in technology, the access to data, and making that available across your end-to-end network, what it might look like in 5 years' time is very different from today.
Products, workforce, industrial assets will be connected. Collaborative robots will support the operator to work in a better and a safer way.
It's going to be enabled through technology, through ecosystems, through people and capabilities that only we can dream of at the moment.
The changes that we are seeing in the market are quite dramatic. And if organizations aren't looking for where disruption has come, they're going to be disrupted themselves.
I think historically, supply chain was relegated to being a back office support function. I think as we move forward, it's not just about having a great product or service, it's about delivering a great customer experience.
Robotics or AI. For supply chain professional core capabilities.
Okay, so supply chain is responsible for giving you the customer satisfaction. Let's say if you have ordered a mobile today and they are saying that within 24 hours or 48 hours the mobile will be delivered at your doorstep, and if it does not come on that time, what about that? If they come and cut the sorry figure, sir, वहाँ पर traffic jam हो गया था, या plane उड़ा नहीं, या lockdown लगा हुआ है. Ultimately, you are a customer, you have paid money, so you should get it within the time what has been given in the online ordering system. So, in order to improve upon the customer experience, you need to be having a very good supply chain or efficient supply chain.
The supply chain industry needed a revolution, and Future Supply Chain had the vision to implement it. The vision? To be an integrated supply chain solutions company, optimizing cost and efficiency through investments in infrastructure and implementation of technology and automation. As the revolution took shape, change was everywhere. And change was delivered. From lifestyle to retail, automotive to food and FMCG, anything else you can imagine, FSC brings comprehensive solutions for everyone. FSC has an extensive network of facilities. Contract logistics, for instance. Technology-enabled distribution centers boast customized warehouse design, which are built to suit multi-user and scalable, while taking into account user safety, vehicular movement, ease of operation, and fire safety. The DCs are run on WMS that can be customized and integrated with the customer's ERP systems. Contract Logistics offers the automated high-speed cross-belt sorter and put-to-light sorter. Express Logistics. The time-definite transportation service offers point-to-point, less than truckload service across pan-India branches, franchises and hubs. Equipped with GPS-enabled vehicle tracking system that is integrated into the Transport Management System portal, the process is completely digitized. Temperature-controlled logistics. Maintaining adherence and regulatory compliances to reduce spoilage. This service includes facilities for frozen, chilled and ambient environment, backed by a GPS-enabled reefer transportation. The storage facilities are equipped to handle temperatures ranging from -25 to ambient, along with multi-temperature trucks and skilled professionals. And the services aren't without appreciation.
Application of technology in the warehousing space.
Okay, so this was all about your technology in the supply chain. Now, this is something which I wanted to stress upon. These are the figures which each one of us needs to understand. So 2003, it was population was 6.3 billion and connected devices were 500 million. 2003, very less. 6.8 in 2010, 12.5 billion. Now see drastic change, 500 million to 12.5 billion connected devices. And then it has gone exponentially. In 2015, it has 25 billion, and 2020 right now, or 20 previous year, 50 billion connected devices were in the market. And the future is going to be huge because everything is going to be connected. So this is something which is a projection from the past data. You can imagine the huge scope of these devices. And I'm not talking about the mobile phone because mobile phone happens to be one of the connected devices out of these 50 billion. But there is a huge chunk of those devices which are used to the factories and to the different industry sectors, and where the students can hope for getting the opportunity to serve. So this is the basically area where you can see your future. So additive manufacturing is nothing but 3D printing. I think you all might have known it from long time. You might have the lab for this. Just going to play this one.
3D printing easy for users of all skill levels at every stage of the printing process. During the printing, X-Rise uses our patented augmented polymer deposition process that combines industrial material extrusion and functional inkjetting. Functional inkjetting allows supports to easily peel away from the part while maintaining superior surface finish and vibrant CMYK colors. This innovation in materials and print process delivers parts with best-in-class Z-strength. X-Rise provides exceptional value for customers for applications across prototyping, tooling, and end-use service applications in manufacturing, package design, AEC, consumer products, and medical fields. Users can print a secure QR code that connects the part to their entire digital ecosystem, which could and authenticity. For SolidWorks and other design programs, our add-in enables users to bring a part into the Rise One-Touch Slicer with one click. Then, with Rise Connect, users can remotely manage and monitor their X-Rise 3D printers. They also receive notifications, queue jobs, and manage an enterprise print farm. With X-Rise, users accelerate their design, manufacture.
Okay, so this is I think the last slide we have got, and we are on time. It's 1 o'clock. So 2015 to 2020, what has changed? You can see it here. 2015, creativity was at the lower most portion, that means on the 10th, but in 2020, creativity has got importance. Critical thinking, complex problem solving remains the same because there are so many complex problems which still needs to be solved. One of the problem I can tell you is maybe the global warming. Then another can be pollution in the metro cities. all kind of these are the complex problems which needs to be solved, and there should be an improvement. People management is, see, automated tasks which used to be done by the people earlier, all these tasks are gone. Now, managing the people is a different thing where we are not actually talking to a robot or dealing with a robot. It's an actual human being who has got his own thinking. So that's why the people management has come at the top. Judgment and decision making has gone down because now there are so many decisions we don't have to take. Yeah, the decision can be taken by your mobile phone on your behalf if something goes wrong at your home, and if it is a smart home, then obviously all kind of parameters can be taken care of. So you don't have to worry about that. You don't have to stress on this. And with this, thank you so very much for your patience hearing. And now we are open to the questions. I hope I have lived to your expectations, and
Thank you so much, sir. As we all see in the comment section, everyone is liking your presentation. So I don't need to say anything about it, but I must say, sir, it was quite an insightful and knowledgeable session. And the videos that you included were quite knowledgeable. So now I would say to our participants, if they have any queries, they can raise their hands and we will unmute them so that they can ask their queries to Dr. Ashwini Sharma, sir.
Sir, this talk was wonderful and informative. Starting from the basics to the today's knowledge base. You explain everything step by step.
So yeah, thank you so much. I think if questions are there, anyway, we are connected.
Definitely, sir.
Yeah, professors, the students, you don't have to worry, your professors are connected, okay? They are also industry 4. Or education 4.0 type of professors. So don't worry about it. If you have any question, if we are not able to answer right now, you can talk to Chaitanya Sharma Saab, and he will get connected to me. Chaitanya sir, I have one proposal to you here.
Yes, sir.
Is that, see, connection is okay. You and me are connected. Now I think it is the right time for us to connect our institutes, means our students with our students to your students in whatever platform. It may be fun, not an issue. But actually our people needs to be connected. What we are doing and deliberating in the class, telling the stories, but it's not happening in the real time. So what I have thought of, sir, is to connect with all my students who have been there maybe 20 years back or whatever into the industry or academics, and getting their students on board. Yeah.
Advanced University, Calcutta.
Yeah.
Private university.
Yeah, so
definitely we can work in integrating both these institutions to work together to provide common platform for the faculty and student to utilize the capability of these two institutions in a better way.
Yeah, sir. So what we are doing now, we are coming up with a small program of talent hunt here. Let us start with the fun. Let's not start with the technical jargons. We can go with that later on. So this invite will be sent to you, sir. This invite will be sent to you. Share with your students. They can view what is going on here and they can comment on that. That's how we can connect our students with your students. And then later on, let us have a kind of platform for all the students where they can showcase their potential and they can understand what is new or latest in the market. So we can tap on our potential as well as on our students' potential. So this is my humble submission to you. And if you are agreed to it, I will send you the invite for that.
Definitely, sir. I am fully agreed with your proposal. We will work together in future.
Yeah, and any of the student who is coming down to Calcutta, you might not be far away from us. So anytime you are coming down to Calcutta, you visit Adamas University, just tell at the gate, or you can call me, take the number from Chaitanya Sharma Saab. You are by default invited, and just ask them that you want to meet the dean, or you can call me so that I will be taking care of you. Don't worry about that. You are my student also, as you are Chaitanya Sharma's student. Okay. So thank you so very much for this amazing session.
Thank you
Sir,
so
there
much
is a
for
question in
inviting
the
us.
sir, there is a question in the
Yeah,
chat
please
box.
go ahead.
Would you please enlighten us about the cyber physical system used in the building industry, oil and gas, ship fabrication, piping, and opportunities, especially in IoT?
Okay. See, cyber physical system we have already seen. Let's say if you are controlling something from your mobile, if you are controlling something from your mobile, maybe a light, this happens to be a cyber physical system where you are physically controlling something. So this is one aspect of it in simple words. Okay. Now, how the industries are doing that, they are programming their machines in that way so that their output is optimized. Coming on to the application part of it and where you can see your future. Mechanical engineers with some know-how of programming and coding. Mechanical engineers with some know-how of programming and coding. Boss, you have got endless opportunities in the world. Endless. You cannot imagine. You have just told some few of them, shipping or maybe oil and gas. There are so many organizations who are looking for some kind of brain who can create the value for their product. Please remember, it is not a thing like you have studied something, done a practical, and then you are going for the job into the industry. Please remember. Now, if you ask me for some kind of job, and if I'm an industry person, I will simply ask you, you go through with my industry, whatever product we are manufacturing, and let me know what value you can create. This is the basic fundamental nowadays, and that's why this creative thinking and critical thinking has come onto the top as a desired quality in the candidate in 2020. So it is a huge demand. So if you see any of them, if you have got innovative mind uh, uh, in place, I don't think their placement or job is any issue. Rather, I would suggest, if you have got an innovative mind, come up with something beautiful and start on your own. It's going to be huge. And if it is into the computer field or maybe the field which is actually catering to the requirement of the people in the industry, please go ahead with that. And there will be so many opportunities which you may not be able to imagine right now. Yeah, any other question?
Hello. Am I audible?
Yes, sir.
Yes, sir. You are audible.
Yeah, I have. Thank you, Professor, for a very nice lecture, comprehensive lecture, and where the industry is moving. I
Thank you,
just
sir.
have two things to suggest or ask, I would say.
Sir.
The number one is that with the existing knowledge, when we try to extrapolate the future and Industry 4.0, I have seen that a lot of things actually doesn't take shape like that, because there are a few examples which I can quote from your presentation. You talked about smart grids, where we talked about smart homes. But what I see is that there is going to be, in the next 10 years, there is going to be a lot of work on the wireless transmission. So all the transmission system and kind of connections which we see is going to vanish. The other important thing is, by the time somebody was trying to modify existing cars and convert them into flying cars, somebody actually created the UAVs and drones and those kind of things. So the entire industry get vanished in between, and all the effort in that direction got lost. That's point number one. So I think I would suggest the audience also to look at from the innovation point of view, and some of the industries will just vanish. So simple extrapolation of the existing knowledge may not lead to the industry 4.0. The other point which I thought I must put here, because I was there in one of the FICCI conferences lately, where the industry was talking about industry 4.0, and in the BRICS white paper development, when we tried to evaluate where are we exactly right now in terms of 2.0 or 2.50 or 3.0 or 4.0, and we could evaluate that India, South Africa somewhere 2.5, China somewhere close to 3.0. And then after a lot of entire day deliberation, what emerged is that uh, the robotics may not be the future, but the cobotics, as one of the videos actually suggested, where we actually work along with the robots. And in the discussion, it also emerged that uh, 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 the future classes also will modify along with the industries. So there was a concept of education 4.0 as well, where we have teaching factories, where you have the classroom and also the industry at the same place, and you kind of read the theory in the class and go to experiment in the lab and also do all those things. I think that also should somewhere come, and a disruption model disruptions which are happening in the existing scenario must also be discussed that ways. So that was my point. I thought I'll suggest on those lines.
Yeah, thank you so much for your kind words. You are right. Not every technology is going to sustain into the market. Like now, the electric vehicles are coming, and government is forcing to buy those. Later on, it may be some other technology by maybe fuel cells and all, and hydrogen is also being worked upon right now. So yeah, it is there, but there is a this is a clean source of energy. So if something is good for the entire society, that may remain, and nobody knows what the future will be. Coming on to the second part of it, sir, I must submit it here that whatever it is, see, these are the jargon words which comes through, I don't know who gives those names, but I don't think in education sector there can be alternative of maybe a kind of classroom where we are present physically. The kind of dynamics which happens maybe for 50 minutes or so, when deliberation, thought exchange, and all kind of brain working which is going on into the classroom, I don't think in coming times it will be replaced. The situation, let me give you an example of it. Why it is so that our ancestors used to have the classes under the tree? Why they could not? They were the genius. They were the genius people. They could have given the assignment, and the students might have learned out of that. But some kind of this thing which our ancestors who were very genius defined a system, and that happens to be still the best system. You might agree with that. When you go into the class, greeting with the students, taking the name of the students, and seeing their faces. Right now, we are not able to see faces of number of people. We do not know what they are doing. And this thing, when it happens in the class, then happens the great learning. So technology, yes, it aids to the learning process, but it can never replace this. So you're right in your deliberations, sir. Thank you so much.
Thank you, sir. The idea is not to, change the mode, but bring the factories into the same campus where.
Yes.
So that was Industry 4.0 people were discussing. I thought I must, because the lab is little weak, where we must focus.
Sure, sir. Okay, so if you have any other question, it's already 1:15.
Thank you,
people
Professor.
are. Thank you, sir. Thank you, sir. People might be hungry. You might have to go for the food.
अरे यार ये तो फर्स्ट टाइम इसको इसमें सेटअप ही दिखा रहा है क्या करवा दिया
Have more
Sir.
questions, they can ask.
Now you can propose the vote of thanks to sir. Before that, I, on behalf of myself and entire organizing committee, thanks sir to accept our invitation and deliver this wonderful talk to enrich our knowledge base. Thank you, sir. Hope
Thank you
to get your cooperation in future also, sir.
Thank you, sir. It will always be available.
Sir, sorry, sir. Don't call me sir or sir. That do not suit me.
Okay, Chaitanya, it will be done. It will be done.
This will good.
Right.
Now I would like to give vote of thanks to Dr. Aswini Sharma sir. every industrial revolution brings along a learning revolution. This quote by Alexander de Cruz I, Preeti Chaudhary, on behalf of Mechanical Engineering Department, BIT SINDRI, would like to thank Dr. Ashwini Sharma sir for speaking his valuable time with us and sharing his deep knowledge with all the participants present here. Thank you so much, sir, for coming here and enlightening us with your knowledge.
Thank you so much. May I take your leave now?
Yes, sir, sure.
Yes, sir.
Thank you so
sir.
much. Thank you so much.
Thank you, sir.
Bye and enjoy.
Bye, sir.
Thank you, sir. Thank you so much.